Okay, ladies and gentlemen, good morning. Let's see if our audio is up and running. It looks like it is. If I ever want to know, I'm going to bring out a special triangle again. Okay. And what kind of triangle is this? It's a right triangle. How do you guys know it's a right triangle? Has a right angle. That's supposed to be a right angle. That measures what? 90 degrees. Good. So this is a right, ladies and gentlemen, angle. And that does make this a right what? Triangle. Another triangle. By the way, do you guys know what trigonometry kind of is? It's the study of what? It's the study of triangles and even circles. You study circles and triangles. So this is a special triangle, right triangle. What's the most famous fact about this? I'm going to do this. I'm going to represent it a little bit differently. I'm going to say this is maybe A, this is B, and then this is C. What do I really mean by that? Do you guys know? I mean A is this length. It's the length of that side, okay? So that's what that means. And then B here measures the length of this side. And then C measures the length of what? This diagonal side. Do you guys happen to know what are the names of all these sides? Anybody know what the names might be? What do we call these things? Yeah, which one's a hypotenuse? C is your what? Hypotenuse. And then what is A and B? Yeah, they're both legs. So you have leg A, leg B, you got hypotenuse C. This is a right triangle because it has a right angle. All right, what's the most famous fact? You guys know this fact is so famous. It's older than what? Oh, how is it? It's older than. Do you guys know that this fact was known since before Jesus Christ? You go, Mr. Judge, this isn't church. This fact is thousands of years old. It's the Pythagorean theorem. What is the Pythagorean theorem? A squared plus B squared equals what? C squared. That's what I'm getting at, okay? And so you got the legs, you got leg A, you got leg B, and you square them, and that's equal to C squared. And so, ladies and gentlemen, this fact is known since before Christ. It's ancient, is what I'm saying to you guys. All right, you guys okay with that? A squared plus B squared is C squared. Okay, so here's an interesting thing, right? You know, what I like to do, sometimes I talk to people and they say, you know what? Why do I even need to know math? What's so important about that subject? Boy. How did that happen? Well, I'll tell you, you wouldn't even have an iPad if there wasn't for math, so. In fact, you wouldn't have the internet. You wouldn't have a lot of things. You probably wouldn't have everything without math. So those people that say, ooh, why is math so important? Ooh, all those little, the drama they create. It's like, really? So here's a question I like to ask people, right? Here's one of my most important questions for people is that, sometimes I'm going to create what's called a unit square for you guys, so you guys can see that here. Because this is kind of where this triangle comes from, right? One unit, one unit, one unit, one unit. There's supposed to be a square. Now, let me do a better job, because a square might get mad at me if I can't do a better job there, okay? Does that look like a square? Anyway, you guys get the picture. Okay. All right. Can I ask you guys a question? See where I'm going with this? What's the length, ladies and gentlemen? What's the length of that hypotenuse? Well, a lot of people don't know. You know what the most common answers I get? You know what people will say? 1. And I'll say, nope, wrong. And they go, oh my God, if my legs measure 1, the diagonal there should also be 1. No, sorry. What's the second most incorrect answer? 2. We go, oh, that's 2. No, sorry, that's wrong. So this is information that people have known since before Christ. Isn't that kind of sad? All right. So you might say, well, how do I know what this is? Well, to let you guys know. These are legs. The Pythagorean theorem says what? 1 squared, which is a, plus 1 squared better be what? C squared. Is that true? So on the left side, you do arithmetic, order of operation. 1 squared is 1. 1 squared is 1. Then we get c squared. And what's 1 plus 1? 2 is c squared. And then I'm going to use a little bit of logic. I'm going to say c squared is what? 2. I can switch the order. Jennifer Lopez is J-Lo, or I can say J-Lo is what? Jennifer Lopez. There's a logic behind the word equal. Is the same as, I can switch that. And then you might say, okay, this gives me c squared, but it doesn't give me c. So how do you guys get c? Do you guys know? You're going to use the what? This is another algebra tool. That tool that people say you guys already know how. You guys already know. You're going to use what's called the what? The square what? Root formula. So what's the square root formula? Do you guys know? I'll give it to you in terms of algebra. If x squared equals n, then you know what we can say? X is plus or minus the square root of n. This is a formula in intermediate algebra. So how we use it here now is to say, well, we know c squared is 2. Then how do I get rid of the square? We say c will be plus or minus 2 solutions, the square root of 2. However, what that means, again, plus or minus, is there's 2 answers, right? C is positive square root of 2. C is what? Negative square root of 2. And then I'm going to say to you, in algebra, those are your solutions. So in algebra, what you would say is, I know I got 1 solution, I got 2 solutions. However, in geometry, we throw out the negative solution. In geometry, why do we throw it out? Because distance, which is c here, is never negative. So we don't have negative distance. So the answer here is really the square root of 2. And ladies and gentlemen, this gives rise to numbers that are called irrational. So in other words, what is ancient is that these irrational numbers popped out. They were discovered by using this Pythagorean theorem. Now, they show up everywhere in other applications, and so, you might say, well, this is a reason why sometimes people study irrational numbers, like the square root of 2, because they're mysterious numbers. These are numbers that are part of your real number line. Now, if I go now to my calculator and I say, hey, calculator, do you happen to know the numerical representation of the square root of 2? The calculator is going to say yes. I can go second, square root, put the 2 in, and hit enter. And so now, ladies and gentlemen, guess what we get? This is an irrational number. The square root of 2 is irrational. So if I had to write a numerical answer here, what do you think I write? Does anybody know? What do I have to write for a numerical answer? Because how do we even use these numbers? Because an irrational number is never ending. What I might say to you guys is approximate to the nearest indicated place value. So I'm going to approximate the square root of 2, ladies and gentlemen, to the nearest what? Tenths. You with me on that? Okay, let's not do tenths. How's that? Let's do maybe hundredths. Oh, no, let's do what? Thousandths. Maybe hundredths. Which one do you guys want to do? Let's do hundredths. So if I go now to the what? Hundredths position. We got tenths, we got hundredths. This 1 is in the hundredths position. You look at the digit to the right and it's a what? 4. You guys with me on that? What does that mean? Do you guys remember? If that digit to the right is a 0, 1, 2, 3, or 4, we just simply what? Leave the digit in the hundredths position alone. So this is how we're going to approximate as an example to the what? Hundredths. So this number here, the square root of 2, we can replace now with 1.41 numerically. Now, what's my point to you guys again? That, here's my point. It's not 1. It's not 2. The diagonal distance is about 1.41, approximately. It's not even 1.5. But the exact answer is in symbolic form. The exact answer is called the square root of 2. So we approximate it. So as you guys can see, approximations are really what? Are really necessary. Is that right? Okay, you guys with me on that? So if I said to you guys now, yeah, we got a few more minutes here. Let's talk a little bit about approximation and place value. Or how about even this? Let's do this here. I'm going to do another example, but I'm going to draw the triangle a little different. Okay? I'm going to do another example. I'm going to say this measures 2, and this measures 3, and we're going to call this C. How do we know that is C? I drew my right triangle differently. How do we know this, ladies and gentlemen? How do we know that's that hypotenuse C, which is what we let it be? How do I know where to put that letter? It's the side that opens up, what do we say? That is opposite the 90-degree angle. So this will always be side C. And so by Pythagorean theorem, we can say what? 2 squared plus 3 squared equals what? C squared. 4 plus 9 is C squared. What's 4 plus 9? It's 13. 13 is C squared. And then C squared equals what? 13. So what does that mean about C? C will be plus or minus square root of 13. Is that true? Because you say, what do I use? Use the square root what? Formula. But in geometry, C is the positive answer. In algebra, there's 2 solutions. So the exact solution for this hypotenuse is a square root of 13. But they want us to approximate. So you say, what is C going to be approximately? Well, let's see, to the nearest tenths. Let's go to our calculator now. And we say second square root of what number? 13. And so we write down 3.60555. I'm just going to go down to the 3 5s. Okay, you guys see that? So what were we approximating to again? Tenths, hundredths position. Okay. This digit is in the hundredths position, the 0. You look at the digit to the right. That's why I always put an eyeball. If the digit to the right is a 5, 6, 7, 8, or 9, what do you guys do? What do you do to the 0? You add 1. So I put a 1. I'm just going to say add 1 to the 0. Is that true? You guys see what I'm saying? So C will be 3.6 what? What's 0 plus 1? Is that 1? Ladies and gentlemen, the numerical representation of that length is approximately, C we approximately 3 point what? 61. So this is extremely important, ladies and gentlemen, to be able to approximate, okay, because we use that process in our computation. So there's a few things to kind of talk about with you guys to review here. You might say, Mr. Judge, I don't remember the square root formula. Go back where? Go back to my website. Where's my website? Get rid of this. Hey. Okay. www.d7judge. And you're in 240. Oh, actually, well, let me see. Did I put it here too? I think I might have put it in 2 places. Nope. Note to self. Put that in 2 places. Okay, I'm gonna do that soon. So I'm gonna put that in your, I'm gonna put that in your website too. But I have it here, intermediate algebra resources. And you go, you have intermediate algebra resources too? Yes. Square root formula is right where? Right here. So you have really square root formula what? Questions and square root formula what? Solutions. So if you want to spend some time reviewing that on your own, well, guess what, ladies and gentlemen? I do have those resources for you guys too. Man, I do hope one day Elon Musk, not Elon, Jeff Bezos maybe buys my website. Man. But before he does, and he charges you for it, you guys have it for free. And so you might even say, and you're going to see this here, if you go to that supplementary here, okay, I even have for you guys for homework what? Pythagorean theorem. They're going to have you find, I did your first question for you. They're going to have you find missing lengths and approximate to the nearest what? Tenths in this example here. So I want you guys to know that stuff's coming too. I got to put some solutions because I got to do it myself. However, ladies and gentlemen, that is in your homework 1. Now, I do have approximation videos too, but I do want to spend some time going over some with you guys. So maybe we'll do that first thing tomorrow morning. So get here bright and early like you guys do. We'll go over some approximation. And that's already going to be published in your what? Let's make that visible. Homework 1. Come on, I'm logged in. Let's make it visible for you guys. Where'd it go? Homework 1 published. Okay, is it visible? Let's see. Said it was visible. Now it's visible. So you should get an alert so you guys could get started. And again, tomorrow morning we'll work on some approximation so that you guys can get the right answers as you're asked, okay? So anyway, I'm not taking roll because I really don't need to, but nevertheless, we'll see you guys tomorrow morning, okay? Take care, stay safe, have a wonderful day. Theorem again. I'll write it down. What is this? Do you guys know? This is still review, by the way. It's still kind of S. It's S-ish. Yeah, you're going to tell me a squared plus b squared equals c squared, but I don't even know what that means. What do you guys have to have if you're ever going to use the Pythagorean theorem? Well, you do have to have a triangle, but you have to have a special triangle. You have to have a right triangle, ladies and gentlemen. Now, that little corner means what? You have a what again? You have a 90-degree angle. That's a corner. And then the length that is the opposite. What does opposite mean? Opens to. The angle opens to the hypotenuse. So that is C. So we always want to remember that is your what? Hypotenuse. It's the diagonal length. And then what are the other lengths? You got A, you got B. What do we call those again? The legs. Okay? And so Pythagorean theorem only applies to what I should say is a right triangle. That is it. You can't use Pythagorean theorem anywhere else. All right. So now, ladies and gentlemen, for example, they're going to say determine the missing length. So in the first example, we got a 4, we got a 1, and I have a C. Now, not all the triangles are going to be 2 dimensions, and I apologize to you guys. What length is missing in this example? The what? Hypotenuse. Is that right? That's what they're talking about, that length. And so, what do you have to use here? Pythagorean theorem. So we were doing this yesterday, weren't we? Okay, we're going to have to find that what again? C. So remember, we just have to plug in the values here for what? For A, maybe we call that A. A goes here, and then B goes where? Here. Is that true? So we're going to have now 4 squared plus 1 squared equals what? C squared. 16 plus 1 is C squared. What is 16 plus 1? 17 is C squared, and C squared is 17. So you know what C then becomes? What do you guys use here? Yeah, you're going to use the what? Square root formula from intermediate algebra. So C will be now what? Plus or minus square root of what? 17. Now remember, that meant two things. In algebra, we would say, C is the square root of 17. And we'd say C is minus the square root of what? 17. But what do you throw out? You throw out that negative sign. The negative value. Now C is the square root of 17. And so this, by the way, is an exact answer. It's an irrational number. It's a simplified radical. And so you do have these issues where your radicals maybe aren't simplified, but you found the answer. And I'm actually going to leave it purple. And the reason I'm going to leave it purple is because this is where you put that answer. That's going to be the square root of what? 17. Now, that is an exact number. Square root of 17 is an exact symbolic irrational number. So if I wake up my calculator, and let's say, for example, they tell us in this determine the missing lengths, and they might add approximate your solutions to the nearest what? Maybe 10th position. They want a numerical representation for C. So we want to say, what is C going to be approximately then? Okay. So get out the calculator and say, okay, calculator, square root of what? 17. This is why we went over the S. So what is this answer to the tenths? What digit is in the tenths position? 1. What's the digit to the right? A 2. What's our answer then? 4.1. So it's approximately 4.1. Ladies and gentlemen, I want to share with you guys here the very reason we did what we did is because this is approximately 4.1. .1 right here. So let's get rid of that. Let's get rid of that. And I'm going to say to you guys 4.1. Is that easy peasy lemon squeezy? That's what we were doing yesterday, weren't we? We were doing these yesterday, I think. Oh, I'm pretty sure. All right. So we do have some examples, but we don't have this example. Let me share with you guys this one here. What if they just have that A, and this is 2, and maybe this is 5? Okay? Notice, what did they do now? This is a right triangle because you have the corner, but what is missing? What's the missing length now? The leg is the missing length, right in here. You guys with me? And I'm not sure what color we use, maybe green. So that is missing. Pythagorean theorem says what? a squared plus b squared equals c squared. And now we know, okay, a is missing. So this is going to be a squared plus, oh, I know, they gave me b. It's right here. They gave me the hypotenuse. It is right here. So I now have 2 squared equals 5 squared. So make sure, ladies and gentlemen, you're correct with everything. All right, you guys see what I'm saying? Okay, now let's do some arithmetic. What is this? A squared plus what? 4 is 25. Now, this again is another, it's really a quadratic equation. This is now intermediate algebra now again. So you're going to have to subtract 4 from both sides. Is that right? And so now a squared becomes, what's 25 minus 4? Isn't that 21? Because you're going to do the arithmetic right here on the right-hand side. So now we can say a will be plus or minus square root of 21. And that means 2 things, by the way. That means, yeah, a is positive, and it also means a is what? Negative. But the problem is, you got to get rid of the what? The negative. This is not algebra, although we're using algebra. Because in algebra, that's a theoretical solution, positive answer and negative. There's 2 solutions. But in geometry or trigonometry, when we're measuring distance, distance is never negative. It's always what? Positive. And so we're almost there, because remember, they want us to approximate our solutions to the nearest what? Tenths. So you get out your calculator again, and if you didn't see, maybe the first one, I'll do it like this for you guys here. Let me clear this out. Well, I'll leave it there. Second square root. Get to the square root. Put 21, enter. And so the square root of 21 to the nearest tenths, could you guys tell me what that's going to be? 4 point what? 6. The 5 is in the tenths. Digit to the right's an 8. Add 1 to 5. Your answer is 4.6. I forgot the color it was. And now, ladies and gentlemen, this number right here is really 4.6 units. Okay, and that is the deal. We got the A value, and that's the distance. That's how long that is. Easy peasy, lemon squeezy. Just working with these right triangles. So those things are coming up using Pythagorean theorem. Right? And then you say, well, what if the other leg is missing? Right? Right? What if the other leg is missing? What if they said, okay, this is a 6 and this is a 3. I'm sorry. 3 here, and the other leg is B. Right? So let's go with our colors. 3. Oh, what's missing here is B. They want to know that length. And they got C. Right? So if you really want to emphasize what this is, that length is 3 units, and the hypotenuse length is what? 6 units, if you really want to go through that emphasis. And by the way, what's a good way to memorize a formula, in case you guys didn't know? Do you guys know how I used to memorize my formulas in math and any other time I needed one? Every time I used it, what did I do? I wrote it down. So I'm going to use the Pythagorean theorem. So what should I do then? Write it down. What is it? A squared plus B squared equals what? C squared. So I'm going to plug in A there. I'm going to plug in B, and I'll plug in C. Now let's plug them in. So that's really what? Oh, that's a 3 squared plus that B squared. I don't know what that is. Equals 6 squared. And if you really, again, want to see all the gory detail with the colors, then so be it. Okay, now what does this give you? What do you guys get? Right? 3 squared is what? 9. Good. So you're going to get 9 plus what? B squared is, what's 6 squared? Is that 36? All right. Now what happens when you guys subtract 9? Right? Your B squared will be, what's 36 minus 9? Is it 25? I don't know. Anybody know what 36 minus 9 is? I think it's 27. Is that right?
Does it matter when you label the legs? Like, is A always the length?
Doesn't matter. So the question is, does this side always have to be A? No. It could be B. Doesn't matter. What does always have to be the case is your hypotenuse. So you can say, you can change the legs all you want, but your hypotenuse you can't do that. Okay, now, how do you solve for B? Do you guys know? What do you guys use? What's this called again? Square root formula. Now, B will be plus or minus the square root of 27. You can go, because this is trig geometry, whatever, you can get rid of the negative solution. Now, what you guys may remember is this is going to be a radical that can be simplified. Now, I do have resources, again, on simplifying what? Radicals. So you might say, what are you talking about? The square root of what? How to simplify a square root. Now, this is studied in what course? Anybody know what course this is studied in? Let's go back to the website here. 241. Do you guys know what I put up here for you guys? Beginning algebra resources, link, and what? Intermediate algebra. Oh my God, Mr. Judge, really? Maybe Elon Musk will buy my website one day, please. Elon Musk or who? Jeff Bezos. Man, you put those resources. Simplifying radicals. See this? I think I do have a video somewhere, and I have to dig these things out. I'm thinking about doing that. Trying to go back to my... Oh, that's number 2, by the way. Look at that, number 2. Look at all this, simplifying radical. I think I have a... well, first of all, to say I do have video solutions for that. This is like the homework back in the day. I do have lectures on it. So you can even see how to simplify the square root of 27, the whole process, and all these others. You can review that, right? Okay, you can review the process that way. And I guess I'll put that in the... Oh, whatever. I guess I have to go back. I'm going to put that link in the comment section, I guess. Or, yeah. All right. Comment section. Anybody go back and look at the videos? Maybe over dinner or something? You doing the laundry? All right. So anyway. So do you guys remember the process? Let me go through the process really quickly for this. You see the 27? Okay, 27, ladies and gentlemen. We're going to do what? We got to find the largest perfect square that goes into 27. Perfect squares are like 1, 4, 5, 1 squared is 1, 2 squared is 4, 3 squared is 9. Those are perfect squares. 4 squared is 16. 5 squared is 25. So the largest perfect square that goes into 27 is 9, and then the quotient will be 3. You know, going into is dividing. The largest perfect square that divides 27 is 9. And then back in intermediate algebra, we use what's called the product rule. You guys can review that. I might try to dig it up. Well, anyway. Yeah, can I dig that up? That might be, where is that stuff? I might find it for you. What's the square root of 9? Isn't that 3? Square root of 3. So in my solutions, you might see this as the exact answer because it is the exact answer. So I want you guys, when you see the solutions, you might see here 3 square root of 3. And I don't want you guys to freak out. You go, Mr. Judge, I thought the solution was the square root of 27. And I'll say it is. But the simplified radical is 3 square root of 3. But then you're going to remember one thing. What do you remember? What did they say to write your answer to? They want a numerical answer. Approximated to the nearest what? Tenths, good. So go to your calculator, and what could you now do then in the calculator? You're going to go to the square root key. Okay? You can say square root of 27. Oops, that's not the square root of 27. Okay. Second, square root 27, and we get 5 point what? What is the approximate answer? Right? Going to the nearest tenths, the 1 is in the tenths position. Digit to the right's a 9, so this is going to be what? 5.2, is that true? So they're asking you guys for the numerical answer. Oh, I guess you could just do square root of 27. But what if you went the extra mile and you simplified because, you know, you say, I want to know what that answer is. Could you put 3 times the square root of 3? Well, let's try this out. What do you think 3 times the square root of 3 will be, ladies and gentlemen? Anybody know? Let's see. Is that the same thing? Why is that the same thing? You guys know, why is that the same? It's very simple. That's the same because, ladies and gentlemen, the square root of 27 is equal to 3 square root of 3. It's the simplified version of a radical. And so, yeah, I'm going to try to see if I could dig that stuff up for you guys. I'll send it to you and let you guys know how to simplify those. But, you know, if you see that it says to approximate your radical because they're looking for a numerical answer, well, there you go. All right. Anybody have any questions on that? Yes. Oh, that's a good question. I'll put that, find that video for you guys. Essentially is this. It's in the process of simplifying a radical. When the largest perfect square that goes into the number that you have here is 1, the radical is simplified. So going into is dividing. So if you said, how come over here we didn't simplify the radical with 21, right? Well, you're going to have to know what are perfect squares. You guys know what perfect squares are? 1 squared, 1. 2 squared is 4. 4 is a perfect square. 3 squared is what? 9. 5 squared is 25. Those are all perfect squares. So when the largest perfect square that goes into that number under the radical called the radicand is 1, it's simplified. If it's not 1, it's not simplified. So 21 was simplified, but 27 was not. You say, why? Because what was the perfect square that went into it? 9. largest perfect square that went into 27, meaning divided was 9. So that process of simplifying radicals in intermediate algebra, is actually, I should say, I think was important, But, how do I say this? The state of California has decided that you guys know this already and nobody has to teach you this again because you already learned it in high school. So we're not going to waste your time to try to learn it again since you already learned it. Yeah.
So for those types of problems, can I just write b is approximately equal to 5.2?
Yep.
Okay.
Yeah, they're going to look for numerical answers and you say b is approximately 5.2.
Just use approximate. Okay.
Mm-hmm. Okay. Should we have you guys try it out? Let's see you guys try this. But this time, I'm going to have you guys approximate to the hundredths. Ooh, you say, Mr. Judge, you're going to make this really hard on me. A 4 7. Number 1. Number 2. B 1 3. And I'm going to say approximate your answers to the nearest what? Hundredths. So I'm going to color to emphasize the missing length here. A is a missing length. What else is a missing length? B is a missing length. And we're going to approximate to the what? To the hundredths. You're going to determine the missing length. I'll give you guys some time. Okay, you guys ready to go over this? All right, let's make sure we get rid of the clock and okay. So for the first one, number 1, what do we write down? Do you guys know? We write down what? A squared plus what? Plus 4 squared will equal what? 7 squared. Are you guys okay with that one? Okay, so then that means a squared plus 16 equals what? 49. What do you guys do now? You're going to subtract your 16 from both sides, right? And so what does a squared become? What is that 49 minus 16? Does anybody know? Is that 33? Okay. So then a will be plus or minus square root of 33. Now again, we only care about the positive solution because this is distance. Distance is never negative. Now you might say, what's the largest perfect square that goes into 33? And I'll tell you, 1 again. 1 squared is 1. That's a perfect square. 2 squared is 4. 4 is a perfect square. 3 squared is what? 9. 9's a perfect square. Has to go into the number with a 0 remainder. This is what we mean by divide, right? 5 squared is 25. Does 25 go into 33? What comes next? 6. What's 6 squared? 36, does that go into 33? With a 0 remainder, you know what I'm saying? So this is already simplified. But they want us to approximate this. They really want a numerical solution. So the numerical solution is going to be second square root 33. Now to the nearest hundredths. And then you tell me what digit is in the hundredths position. It's the first 4 going left to right. What's the digit to the right? A 4. So what's this going to be? 0.57 what? 4. Is that true? 0.574. And ladies and gentlemen, there you go. They wanted the numerical answer, and this is all the work, okay? All right, you guys okay with that? Easy peasy? Okay, 5.74. That's the distance for A. That's what they're looking for. Good. Anybody have any questions on that first one? What about the next one? What are they saying here? What do they want here? They have what? 1 squared plus b squared is what? 7 squared. Is that right? So what is 1 squared? 1. 1 plus b squared is, what's 7 squared? Oh, was it 3? I apologize. 3. So I got to get more coffee. Thank you. So what is 3 squared? It's 9. Good. Let's make sure we're okay. All right. Subtract 1 from both sides, right? And now you have, what is b squared going to be now? B squared is going to be what? Do you know what 9 minus 1 is? Is that 8? Okay. And then now you say b will be plus or minus the square root of 8, but you guys know we take the positive solution because distance is never negative, so we have the positive answer. However, is there a perfect square that goes into 8? It's 4. Good. So when you simplify that radical, right, you say 4 times 2, because that's the quotient. What we mean by goes into, the perfect square 4 divides the 8 2 times. 2 times 4 is 8. There's a 0 remainder. This is what we're using. So replace the 8 with the 4 times 2. Since 4 is a perfect square, and we use the square, we use the what? Square root of a product. Product is a square root. 4 is that perfect square. This solution is really 2 square root of 2. So this is the exact answer. This is a symbolic answer. So in my solutions, you're going to see both. But what did they want you to give the answer to? What did they say? They want the numerical answer, the approximation. So give them the what? Numerical. Meaning you can do either. You can go in your calculator and say what? You can say calculator. Maybe you guys need to see some of that. Square root of 8 or 2 square root of 2. Does that give you the same answer? Isn't that the same? Okay. So what are we approximating to? Hundredths? Okay, so what's the hundredths? 2 is in the hundredth position. What's the digit to the right? So what does that mean I do to the 2? Add 1. So what's your final answer? 2 point what? 83. So ladies and gentlemen, there you go. Easy peasy lemon what? Squeezy. All right, now here's what I'm going to do for you guys here. I'm going to have you guys recall something here. I'm going to go back here. And let me copy this picture here. And again, I'm going to ask you guys to remember now a little something from me. Okay?